Fusion Mobile, quality e-learning experience on the go.
We are going to look at Earth's internal processes of landform development. Now, if you look at your SS2, we talk about the external processes of landform development. Even in your SS1, we talk about these external processes at elementary level. We talk about the processes like rock formation. The different types of rock, igneous rock, for instance, is formed as a result of volcanic activities. And when we were treating that topic, if you could remember, I did say that when you get to SS3, we are going to look at it in a more detail. Now here we come. Also, when we're looking at mountains, we talk about volcanic mountains. And I did mention that when we get to SS3, because I told us that time that there is a type of movement that is exhibited within the internal structure of the earth. When we started geography, we look at the shape of the earth as being spherical. We also talk about the movement of the earth, and then we crack a joke. How can you say that the earth moves? But I told us that the earth exhibits two types of movement simultaneously, rotation and revolution. And we demonstrated it then, if you could remember. But when we are talking about the internal processes of landform development, we are now looking at another type of movement exhibited within the earth structure. Remember, when we discuss, that is why I said SS3 work is a repetition, but a little more advanced of what we have done in SS1. Now, when we're discussing the structure of the earth, if you could remember, we said that the structure of the earth is divided into two. We have the outer structure and the inner structure. And if you remember, then I told us that the inner structure is divided into the mantle or the mesosphere, the core or the barysphere, while the outer structure is divided into what? The atmosphere, the lithosphere, the biosphere. Now we are going to look at the formation of the earth movement within this internal structure of the earth. Now we are going to look at earthquake. We are going to look at underground water. We are going to look at karst topography. So these are the underground features, the process of landform that are found within the underground system. When the action vibrates to the outer surface, you and I will feel it. We have heard of earthquake in Indonesia, killing people, or tremor in Kaduna. They just woke up in the morning and they saw the land vibrating and everybody was running helter-skelter. Or in some places we heard that the ground just opened and swallowed people. Tall building began to fall off and all that. Everything scattered, houses, properties worth millions, were destroyed. That is what we call an earthquake. Then we have underground water. This underground water, many of us, we drink water, either borehole, we have well in our house, we have, maybe government provide water or we provide it ourselves. We have underground water. How is this underground water formed? Then there is what we call karst topography. Karst topography, another name for karst is limestone. That is a sedimentary rocks that is made up of a limestone. This is what we mean by karst topography. Let's look at them one after the other. Number one, earthquake. What do you understand by earthquake? Earthquake is a type of vibration that occur within the earth structure. Remember, there is the internal structure of the earth is in layers. Remember the formation of your igneous rock, the formation of your volcanic mountain, and so on and so forth. They are in layers. Here we have the what? We have the core. Then another layer we call the mantle, or what? The mesosphere. Think you can still remember. Then another layer we call the what? The lithosphere. The lithosphere. Then we have the other layers, the biosphere, then the outer layers, the atmosphere. The atmosphere is also divided into layers. We have the troposphere, we have the exosphere, we have the ionosphere, and so on and so forth. But our concern is not the outer sphere. We are talking about within. If you remember when we're discussing the formation of volcanic mountain, the formation of volcanic plateau, the formation of igneous rock, I did tell us that this core, or the barysphere, is made up of a magmatic material. Magmatic material. This material, they are boiling at a very high degree, and any little, you know, to this end, what happened is there will be bend to come out. But in the case of earthquake, what happened is the distortion. Any little crack, any little fissures, any little line of weakness that can extend from the outer surface to this zone will force these magmatic materials outside. That was what we discussed. It may lead to volcanic mountain, lead to igneous rock, or volcanic plateau. But in the case of earthquake, what happened is that these arrangements, that is what we mean by the tectonic plates. This arrangement is called the tectonic. The tectonic arrangement is being distorted. It's just like you arrange your textbooks on top of each other in layers, maybe mathematics first, geography, English language, and you put it on the table. Then under or in between mathematics and geography, you have a pen that you want to remove. Immediately you remove the pen from in between this, what happened to the arrangement? It will be distorted. And once it is distorted, if the books were not well arranged, they may fall off. That is what we are talking about. Immediately there is distortion in the arrangement of this tectonic, the mantle, the lithosphere, and the barysphere. You know, once there is distortion in the arrangement, it will now lead to what? It will cause a vibration. And this vibration will now be what? Be extended outside, because it happened within. Once there is vibration within, the first place that this vibration will be sent to, the message, is the earth surface. And once this vibration happens, is what we call the earthquake. What we mean by quake is to shake. That is, for instance, you are building a house. You are laying blocks on top of each other. When there is this distortion at the basement, what will happen to the whole of the blocks? Everything will now collapse. That is what we mean by earthquake. Now, the earthquake will send a kind of wave outside. This wave, because as a result of the vibration, it will send the wave outside, and this wave that is sent to outside will now expand. It will transmit to, as you know, as far kilometer, depending on the intensity and the seriousness of the earthquake. So here we call the epicenter, the focus. That is where the earthquake, the point at which it happened. Then here is the point at which the earthquake originates, and we call it a focus. That point we call it what? Focus. Then we have we can begin to transmit the waves outside. We have the primary waves, we have the secondary waves, and we have light or love waves, as the case may be. So when we are talking about earthquake, we are talking about the distortion in the arrangement of tectonic plates within the earth's internal earth structure. And once there is distortion, what will happen is you will feel the vibration. This vibration that we feel as a result of this distortion within the earth surface, within the internal structure of the earth, is what we call earthquake. To quake means to change, to shake. When something is being shaken, to destructions of buildings. It can lead to destructions of road construction, because everything will be distorted from underground. That is what we mean by earthquake. Now we are looking at internal structure, internal processes of landform development. Now let's look at what we called underground water. Underground water is, when rain falls, three things happen. When rain falls, three things happen. Number one, infiltration. Infiltration happen. Number two, evaporation happen. Then number three, erosion. Some quantity of water can be eroded into a bigger water body. Other can be infiltrated into the earth surface, into the underground surface, then the evaporation can take place. So these three things happen simultaneously. As this water continue to percolate, to infiltrate into the underground system, it will get to a zone where these are a rock that will disallow this water to pass through, and thereby form what we call underground water. When you are dealing with underground water, there are things that you need to know. Number one, the nature of the rocks in that environment. At times you may be surprised. There are some places you go, you drill a borehole, you cannot get water. But you go to some place, you didn't even go deeper, some meters deep, you begin to get water. The reason is because of the nature of the rocks that we have within the basement complex. Now, what are those? There are some rocks. Rocks underground are divided into, number one, we have a pervious rocks. Pervious. Number two, we have a porous rocks. Number three, we have impervious rocks. So these rocks are found within the underground system. What do you mean by pervious? A pervious rock is a rock that allow water to pass through. What is porous? A porous rock is a rock that does not have pore. The pore, like sandy soil, sandy soil is a rock. This rock has no pore space at all. So once the water touches, it can disappear within. So that type of rock cannot have the ability, the power to retain water. But when we talk about impervious, these are rocks that do not allow water to pass through. So these rocks can form what we call aquifer. Yes. In other words, what we are saying here is that an impervious rock is a type of rock that do not allow water to pass through. If you remember, recollect my explanation, I say that when it rains, three things happen, and it happens immediately the rain, begins to fall. The first thing that will happen is what we call infiltration or percolation. The water begin to infiltrate into the underground. Then number two, we have what we call evaporation. The water begin to go back into the atmosphere in form of vapor. Then number three, the water begins to flow. So these three things, happen immediately. But the one that goes underground to form underground system of water is what we are discussing. So there are some rocks that will allow this water as it's going down to pass through them freely. There are some rocks that do not allow the water to, they don't even have the power to retain the water at all because of their poor porosity. Then number three, we have impervious. These are rocks that do not allow the water. So it depends on the arrangement of this type of rocks within the underground. Therefore, it is these rocks that determine the underground water storage. Where we have, an underground system that the aquifer or the impervious rock is close to the earth surface, you should know that that place has the capacity to produce enough underground water. But a situation where you do not have, when we are talking about porous rock, example of a porous rock is a karst environment. Karst is a limestone environment that have a very high porosity, and most of the springs that we see, are found within the karst environment. Spring, that is the water that outlet back after getting to the aquifer instead of staying there because of the porosity nature of the rocks of the environment. Either within the karst environment, the water will come back in form of a spring, in a karst environment, karst topography. The place is very porous. It's made up of limestone, and the limestone it has a very high porosity. The water can just go through it freely. So these are what we call the earth internal processes of landform development: the earthquake, underground water, karst topography.